Welcome to the second part of this series. Now that we've gotten past, whatever, now that we've gone past all the pretty monotonous talking, we can actually get into the interesting stuff, which is making an ESP, because that's kind of what we're all here for. So, thankfully, there's already this test code. We're going to go ahead and look at this. I already explained a bit of C-based entity. Now, if you use Java or C# mainly a lot, you often do not use pointers, if ever. In C++, you are going to be throwing these everywhere. Yeah, like everywhere. And you're also going to want to get used to the GDrawManager class right here. This is a single instance class, so it's just made to kind of organize the code, keep it all in this one class right here. In fact, just for the sake of keeping it short, I'm just going to press Ctrl+R and then just rename this GDraw, because I really do not like typing lengthy names. So we're going to look at this code really quickly and see exactly what it's doing. So we have our C-based entity, a pointer, which is, points to a location in memory. That means this, no matter, if we do or do not assign anything to this, this will still contain information from the entity we're grabbing here. Because, it's always pointing to it. And this function here will grab an entity from an index. Now, what happens is the source engine likes to store all their entities in a really big array. And they have a function here which you can use to get an entity at whatever index you like in the array. Now, me, right here, is just short for a function that gets your index in the array. So this will get your position in the array. It'll get a pointer to that info and then puts it in this little variable, which is really fancy for your player. So we'll just rename it that. We have these pointer checks here. You always want this because not all these spots in the arrays are going to have information in it. Sometimes it'll be a blank. So if it's blank, you want to make sure it's not. If it is, you just want to return and skip the code, because you will get crashes when you're trying to retrieve information like your world position. And now if we look over here, this is where things get really interesting. We have this vector world and vec screen. So vec world right here, we use it here, your player.get world space center, which is actually just super fancy for get your player's position in the world. This gets the center of your player. Now we can assign it to vec world, so now we have our world coordinates. But before we can draw it to the screen, we actually need to turn that into screen coordinates. So we have this function right here, gdraw, and we can do .world to screen, another really nice sounding name. And we have, and we have vec world and vec screen. So you input the world coordinates, and then you put in the variable you want it to assign the screen coordinates, and then you can see right here it just draws on those screen coordinates right here and here. So now that we know how that works, we just want to do this, but for everyone, not just yourself. So what we're going to do is we're going to make a kind of a for statement. And one last thing really quickly is you'll notice how this is an if statement. Even though you're just getting world positions, what does this have to do with an if statement? If you right-click and peek definition, this is actually a boolean, which returns false if the object isn't within view. So if you can see, it returns true. So summarized up, this draws a crummy watermark. This gets the info to your player, gets the screen position, and makes sure you don't get a crash. And then it just draws it all on the screen. It says if the player is visible, then draw on the player. So let's go ahead and change. Since this is our original cheat, we are going to change this name to something not original. So not an aware paste. I mean, come on, I swear. Okay, not an aware paste. So we're just going to want to delete all this code, because we don't need this. We don't want to draw ESP for ourselves. That is completely useless. So like I mentioned before, since C-based entity, there's a whole array of them for every entity in the game, we could just create a for loop to access every single entity. So if I equals 1, because we don't need to start at 0, then if I is less than gint, this is your interfaces class, And it has pretty much everything. If you do dot, you have surface for drawing, panels, which you'll get into later, engine for doing stuff like setting your view angles, and ent list, which is what we want. So ent list, and then dot get highest entity index. So this basically tells us how many entities there are in the game right now. So then we do I++, and there we go. Right in here, in this little space, it just loops through every entity in the game. So let's go ahead and get the information for every entity in the game. So C-base entity pointer, and I'll call it current because this is a current entity we're looking at, equals, and then we can do a little shortcut here, get base entity, and then I. And there we go. So it gets it from this index in the array. And now we want to make sure that it's not blank, otherwise we will get crashes. So if current equals null, or current dot is dormant. Whoops. Okay. Current. Oh shoot. Okay. Nice. Okay. Current dot is dormant because we do not want to get dormant entities. And then we're going to do continue. So we're basically saying if we just got a blank, we got a dud, then just skip all the code below this and then continue to the next entity. So now that we have that, we can do, let's see, let's get the world position of the player first. So we'll do vector world pos and screen pos. Okay, so now we have that. Now let's assign world pos. So we'll do current dot get world space center. You know, that fancy terms. Okay, then we assign it to world pos, and then we do if player is in view, or short, you know, a world to screen, and then we input our world pos, and then a screen position. So if the player is in view, then we can just go ahead and draw some text. So draw string. Nice. Now we can input our x and y. Screenpos.x, screenpos.y, and then dward. This is basically short for unsigned long, which is short for really large integer. Now this is useful if you want to do like hex code like color values, or you can just use the color code if you like RGB, and then makes white color, and then set 255 for alpha so that it's not transparent. Then we have our text, so we'll just do some pretty text. Now let's compile and see what happens. Now we have our original cheat. We're going to go ahead and load into the game using svlan1, so VACT isn't checking for cheats currently injected. And then I'll load the item test map. And then I'm condensing all this into one line. And there we go. So while we wait for this to load, problem with this code though is that it will show it'll show every single entity in the game. This includes ammo packs, view models, cosmetics, and all that, not just players. So we need to find a way to rule out the players from everything else. So I already have my injector set. And I have my injector set to just inject the cheat when I click that. So now that it's injected, we have this text just exploding all over our screen. It's not A-where, I swear. So we can do some taunts here, and you can see we are covered in text all over the place. This I can't even tell what these are supposed to be, but some of these are actually your view model. A lot of these are just your cosmetics and stuff. So we only want to do ESP for players because this is just ugly and not visually appealing. So let's go ahead and exit out of the game so we can change some code before we re-inject. We're going to use another little function. Okay, we're going to do a string name equals current dot get client class. This includes some useful information such as the name of the entity. This will give you the type of entity that we're currently looking at. So we can make an if statement out of this and check to see if they are a player or not. So we're just going to go ahead and put a name in here, but wait a second, no, we're getting an error. It says no instance of overloaded function. It's basically saying we do not know why you put a string in here. You can't do that. If you look in the definition, the source engine really likes using wchars, like const wchar pointers, just basically in much simpler forms of strings. So we can actually easily convert this by using .c_stir. Now, if you want to do like good, efficient coding practice, you could just use const char pointer, but preferably I just do a string because we're going to be using this for in an if statement, and you need to use string compare and all that fancy stuff if you're going to do a character array. So let's go ahead and load into our game. Now item test, and let's check out this neat little code. Just admire it for a bit. We're going to press Control-Shift-B so we can build our solution, and we should arrive in map item test shortly. And here we are. Okay, so let's go ahead and play sniper and inject that nitro C++ power. Now we're getting some really good text here. Look, we have light bulb ESP, so now you can see all the lights in the game. It's a pretty neat feature. Not a whole lot of cheats have this. You can also see effects such as light beams and even resupply cabinets, which are C dynamic prop. Let's go ahead and check out our player though. You'll notice there's a whole lot of stuff here. This CTF club, I don't even know what that is. We have wearable, which is short for cosmetic pretty much. So there's one that stands out at the very bottom though. It says CTF player. You'll see that right there. So CTF player is kind of the name of the player entity. So now we know what to do. We can easily rule out the player by doing a quick if statement. So if name equals CTF player and they are on the screen, then we go ahead and draw. Now that would be all good, but oh shoot, no, wrong button. That'd be all good, except it's not appealing enough. I need those nice visuals. Text just isn't good enough. And we can also change this. We could just do, I don't know, player. So we might want to make an ESP box. So to do that, we're going to need at least 2 points on the screen. We're going to need the bottom of the player and the top of the player to kind of get bounds to create our box around. So we're going to avoid immediately bugging out all our code, we're just going to define some new vectors here. A vector. I'll call this upper and lower. There we go. I'm going to go ahead and do upper equals current.get as origin. So this, unlike this one, you could just directly assign it. This, the origin of the player, unlike the center position, is at the very bottom of their feet, so that's perfect. Except this is upper. That's not what I meant to do. Okay, so we have our lower right here equals the bottom of the player, and we're going to go ahead and define upper underneath here. So we're going to do a vector upper equals, actually no, we're just going to initialize it like this because that's easier. And then we can do lower.x, lower.y, and lower.z. Now, right now this is just the same as lower. So what we're going to do is z plus 90, and from 90 hammer units, or whatever you like to call it, above the player's feet is approximately around their head. So we have the boundaries from their feet to their head. So I'm going to want to change this if statement a bit. We don't need this anymore. We're also going to need some new vectors. So vector, I don't know, let's do bottom and top. And then we'll go ahead and do lower and bottom correspondingly. Let's put some little recs in here just to organize this parentheses. And then we'll do a gdraw.world to screen and upper. Okay, there we go, upper and top. So now our bottom and top hold screen positions. So we can still use this text if you really like a text ESP. Okay, and extra little parentheses there. We just need to set this to the center of it. So I'll just go ahead and make an int called size equals bottom.z minus top.z. So this is getting the distance in pixels between bottom and top. So we're going to use this to make a box size depending on how far away the player is. So I'll just go ahead and do bottom.z minus, oh shoot, actually let's do bottom.x. Doesn't even matter which x you use, and then we'll do okay, and then we'll do bottom.y minus, we'll do actually yeah, we'll do top.y plus size divided by 2. Now it seems a bit weird, but this is just getting the center of the player between those two lines, so nothing to be afraid of. Super complicated, I know. And now we're going to want an int x, y, width, and height. Now we're going to assign the x. We can start with the y first. So the y will equal top dot y, which is nice. Oh shoot, this these are screen coordinates. We need to do y, not z. Anyways, so we have this, and then we need to do height equals, well, height is just the size. We already have that defined. But for x, it's going to be a bit different. So we need to make this size depending on the distance of the player. So we're going to do x equals bottom, well actually let's define the width first. So let's see, right here we'll do int width equals, and then we'll do size divided by 2. That's nice. Actually no. Size divided by, maybe, yeah, we'll do size divided by 3. So now we'll do x, and then we'll do bottom.x, and then minus size. And then for, okay, so we have that. And now we should be able to also draw a box. So we're going to use a new little argument here, outline rectangle. It's a pretty spooky function. It's got 5 inputs. So we're going to do our x, y, width, and height, all knocked out. And then we're going to do color code. And we'll just do some nice color right here. And there we go. So I blindly coded this. This may or may not work, but it should give us a close enough result. So we'll just load into item test, and probably just comment this out because this text is pretty annoying. We don't even need that there. But let's just wait for ourselves to load into the game. Let's check over our code really quickly to make sure we did this correctly. So our x is bottom of x minus size, and then we have our height equals size. So we need to do width. There we go. We'll do minus width divided by 2. There we go. So now we kind of had the box evenly centered on the player. So we'll go ahead and add a bot and inject. And oh shoot, that looks nice. So now we have a basic little ESP box, which looks pretty neat. One problem though is like most basic ESPs will do this little trick, which makes it a really simple ESP box. The only disadvantage to this is these 2 points will shrink. Technically, the distance between them will shrink when you're on top of them, but from the side, it looks pretty nice. So I'll call that good for now. You can look up some other tutorials if you want a better ESP box. But we did it. But wait a second, the box is still here, even though the player is dead. And this is because technically when you die, your player entity just sits there still, kind of like spectating around it. We will fix this later when we start getting into net vars in a more advanced ESP in the 3rd part.